Imagine training your machine learning model for hours only to find out that it didn't learn anything. You check your code, your model, your data, and everything seems to check out. You don't know it, but there's a secret bug destroying all of your work. I once spent 48 frustrating hours trying to find it, and ever since then, I've been able to consistently identify it and save countless debugging days for me and my teammates. So today, I'll show you exactly how to find and correct this mistake I made in shuffling my dataset. Think of your dataset like a deck of cards. Shuffling them just means rearranging the cards and making the original order disappear. And when you train machine learning models, it's very important to shuffle your data. But actually doing so correctly is much harder than you might think, because you don't have just one, but two decks of cards, and you need to shuffle them in a very specific way. Let me tell you about a painful experience that I had. A few years ago, I worked on a project where I needed to predict faulty hardware components from their voltage readings. Now, we knew this problem could be solved, but no matter what I did, the model just couldn't learn any learnable patterns. And I tried to debug the data, the code, and I just couldn't find the source of the issue. And after 2 days debugging, I found out that the real problem was that I was shuffling the input samples and the targets separately. So these are the two decks of cards that we were talking about. The samples are what we feed into the model, and the targets are what we want the model to predict. And if we shuffle them independently, we're destroying the relationship between them, and it essentially teaches the model that there is nothing to be learned. Everything is random. Now, there are two things to keep in mind over here. No shuffling is better than bad shuffling, which is what I did in this project, but good shuffling is better than no shuffling. And this is actually not immediately obvious. Bad shuffling is essentially feeding the model garbage. When you shuffle the inputs and the outputs independently, you break the relationships between them, and this essentially teaches the model there's nothing to be learned. Worse yet, some models can even memorize these nonsense relationships you made and fool you that they're actually learning something. It's kind of like studying with flashcards, but someone mixed up the answers to all the questions. So even if you manage to memorize the relationships between every single question and every single answer, you're just doomed to fail in the real test. At this point, you might be asking, why do I even need to shuffle my data in the first place? So it turns out that if you don't shuffle your data, you might get all kinds of weird issues. For example, you might be underfitting or overfitting on certain classes, causing your model to underperform in production. And since you don't have control over the original order of the data, it's generally just good practice to always do this. So here are my 3 rules for how to properly shuffle your data. First, always make sure that you maintain that correspondence between the inputs and the outputs. Always use a random seed to make sure that you can reproduce the results, and it's very important for experimentation. And third, always make sure if you split into train, test, and validation, that the different populations of the data are represented more or less evenly in these different sets. Now, all this theory is nice and all, but at this point, I'm sure you probably can't wait for me to get into the code. So let's do that. But before I do, I just want to say that if you like this video, please consider subscribing and liking this video. It really helps me out. Okay, let's dive into the code. So we're here in deepml.com, which is a great website with lots of machine learning coding problems. And what we're going to solve today is problem number 29, random shuffle of dataset. So let's read the problem together. We need to write a Python function to perform random shuffle of the samples in 2 NumPy arrays. So these are the 2 decks of cards that we have, X and Y, while maintaining the correspondence between them. Again, we talked about this, very important. And we need to support the use of a random seed, which is very, very important. X and Y are both NumPy arrays. And what we're going to do is to ensure the correspondence between them, we're going to use an index. So we're going to have an index array range of the length of Y. So this is going to give us an index from 0 to the number of samples minus 1. And what we're going to do is we're going to shuffle them. So if we do numpy.random.shuffle, this is going to shuffle the index in place. And then if we just return the X using this shuffled index and the Y using the shuffled index, that should be it. But I actually forgot something here. I didn't use the random seed. So what we need to do is set this random seed, and we just do it like this. numpy.random.seed, and now we're really done. So let's see if this works. We'll run the tests. Yep, passed everything. Very nice. One last thing I wanted to mention is that if you work in production systems like I have for many years, you're probably going to use packages like PyTorch and TensorFlow, which handle the data shuffling built in. So if you like this video, like and subscribe, and I'll see you next time.